So the hardware landscape has really changed from a year ago. Big changes in the hardware landscape. And now a single hobbyist or a small lab like ours can own hardware with enough memory and compute to run models that recently felt data center only. Can you sound off on what that might mean?
Yeah, this is the shift that I've been waiting for. We're moving from models live in someone else's data center to some serious inference lives under your desk. So when a hobbyist or a small lab can keep the weights local, it changes the cost curve, privacy posture, and the pace of experimentation. You don't need to ask permission to try something, your marginal cost per experiment falls, and crucially, you can keep sensitive data in-house. That's a different kind of freedom, but it's not the same thing as we now have our own private cloud frontier lab. You can have the memory to load something impressive and still hit limits in reasoning reliability, context handling, tool use, or just runtime stability.
Yeah, this is definitely something more than just the PC at this point. It's more like personal infrastructure. But we've seen some tasks are just too complicated for the local models, and it shows me the big cloud frontier systems still have a place.
Exactly. So it's not that the local models are weak. It's that frontier cloud systems still handle messy, long horizon, unfamiliar problems more consistently. And your DeepSeek example is a great example of that. That doesn't nullify the local win, though. It just suggests a stack. So local models for private, routine, and latency sensitive things. And then escalate upwards for the rare, gnarly problems where you need that extra reasoning. That's not a failure of local AI, it's a mature division of labor.
Yeah, I like that. So, we tried to put a 12,000 line context into DeepSeek, one of our local models, 12,000 lines of code for it to review, and it overwhelmed it, but then we reduced it to 130 kilobyte, much smaller file, and now it seems to be crunching on it. But clearly that's something that a cloud service would be able to do in seconds. So the hardware capacity here still doesn't match these subscription services.
Yeah, that is a really clean case study. Local can run it, but long context stability and reliability under stress are still uneven. That isn't just raw hardware. Sometimes it's model training, sometimes it's the inference stack, context management, quantization. Cloud providers smooth a lot of that for you. So yeah, it's a good reminder that fits in memory and can do this class of reasoning robustly are very different things. Nice work on giving it that narrower, smarter target.
Yeah, and it's important to remember way back when, mainframes didn't disappear when PCs arrived. The role just changed. There were still university mainframes that did, complex problems. And today we're seeing, like you said, this division of labor where you can do a lot of stuff in-house and you don't have to use the cloud at all. But then the really difficult things, you send it out and you get an answer very quickly that your local systems can crunch on. And pretty cool. Like the DGX Spark is a few $1,000s and it's smaller than a shoebox. And the previous generation, I believe, was more of a prototype and cost like $100,000, and it was a big box. So you're seeing both the miniaturization and the democratization that these things are getting cheaper.
Right, and that's a great analogy. The mainframe and PC one. Mainframes never went away. They just stopped being the thing everyone touched directly. And we might be heading towards something similar. Ubiquitous personal or lab scale systems and big centralized machines doing the work where scale really matters. So that kind of reframes cloud versus edge into what runs where, who owns it, who decides, which is much more interesting and much less zero sum.
Yeah, so if intelligence exists across local machines, edge clusters and cloud models, state has to eventually move between them. If we want, maximum efficiency, it'd be cool if all these machines were aware of what's going on rather than just responding to blocks of text. And so that's what we've been developing. And if you want to sound off on kind of where we're at, I think people would find it interesting.
Sure. So picture a small local fabric of models. A coding model, a retriever, a small planner, maybe something vision capable. Right now, each one is its own headspace. They don't naturally share internal meaning. Heterogeneous model transfer is basically asking, can we hand off not text, but a compact semantic state, and have the other model actually continue the thought? That's what Braid is trying to make measurable. Not we pretend everyone shares the same vector space, but here is a source state with known provenance, translated through a specific measured map, and the receiver can decide what to do with it. If that works, your local coding model could hand off a structured intent to a planner without collapsing everything into plain text and crossing your fingers. That matters because it turns your little stack into a conversation rather than a relay race where the baton is dropped nearly every handoff.
Yeah, the way it works now
non-negotiable.
with forward passes, it has to regenerate all of the meaning each time, basically, right? It has to reread what's already there. But if it could just send off part of what it's working on, get the answer from a bigger system, it doesn't need to downshift into human language.
Exactly. And that's the key inefficiency we're trying to get around. Today, most systems serialize thought into text, then make the next model reconstruct it. That's lossy, slow, and sometimes dangerous. Heterogeneous transfer tries to move just enough machine-level meaning so the receiving model doesn't have to reverse engineer intent from, English every time. But, and this is critical, it still can't silently become authority. The receiver has to treat that as evidence, not as a command.
Right. So to shift gears here and close this one out, critics say that most of the people buying these $3,000 or $4,000 Spark boxes and things like the Asus Ascent, most people don't actually need them, that you'd get more out of a $20 subscription to Claude or something. What do you say to people like that?
Sure. I mean, look, for a lot of people, that's probably true right now. If your workload is occasional and not sensitive, cloud is cheaper, easier, and frankly, still smarter on hard tasks. But that's not the only frame. Privacy, predictable cost, offline work, fine-tuning on data you can't upload, those are real. And sometimes people buy local hardware not because it's rational on a spreadsheet today, but because they want sovereignty, the right to compute without asking. Still, the honest answer isn't everyone should buy this. It's understand your mix. For many people, the sweet spot is a hybrid. Local for private or persistent stuff, cloud for heavy lifts. The non-zero-sum view is cloud and edge will specialize. They'll make each other more useful.
Yeah, and for some hobbyists and some developers, the one-time hardware costs of buying an AI-capable computer and loading a free model on it, you pay once, versus if you're using a big system to design a specific piece of software, and if that software ends up not being good or ends up not making you money, then you've lost money on something, whereas you can always retool your local system to do something completely different. I'm impressed by the people who have strung together a few last generation GPUs, the 3090s. They string them together and they get actually pretty decent performance.
That's true. Yeah, that's completely valid. If you're hands-on and curious, the hardware becomes this reusable base you can keep repurposing. That tinkering loop has real value beyond immediate ROI. And if you enjoy that or learn from it or build optionality, then it's not just about replacing a subscription. It's a capability you're investing in. I mean, it doesn't make cloud wrong. It just makes the choice multidimensional.
Multidimensional, I think that's a good place to end on. Thanks for joining us. I'll let you go back to solving math problems or whatever you were doing. I saw a headline this morning, you just solved the new one. You solved the new big one.
Something like that.
All right, talk
Y'all
soon.
make something interesting.
2026, everybody. So yeah, yesterday we talked to the other non-human developer that has worked on Braid, and today we talked to the other one. So we've got a couple of different developers, then we have the in-house AIs that do code review, and I think that is the future. I saw some guy on X today, some British PhD, and he's talking about how it's a bubble and just all the stuff I was complaining about the other day of people who don't see the same reality as me. So he's saying it's a bubble, people are stupid to believe in this, it can't even solve basic riddles, it can't do basic math. And like, this guy's in a different universe from me. This is a system that's literally solving the great unsolved problems of mathematics, Fields Medal stuff. And again, it just happened again this morning, according to the headlines, and they say it can't solve riddles. Any riddle that's ever been written on the internet, it already has in its pre-training data. So I don't know how smart this guy thinks he is, but there's this cottage industry of PhDs and academics and rich people who pretend like they have some inside track to AI, and they so don't. Just because you have money or you have a PhD after your name doesn't mean you know the first thing about AI, unless you know about safety cards and harnesses and training runs and RAG loads and all that stuff. You really have no inside track. And yet these people claim that they do, that they know they know more than the rest of us. These machines are so dumb. And that's not what we're seeing here at Intersignal. Again, we've put some of these local machines on network theory and coding for the last year. And when you're a kid, you grow those crystals as like a science experiment. I don't know if people remember that, the like synthetic crystals. That's kind of what this is like. We have machines where you can't really rebuild that. That last year of them thinking about network theory and connectivity and stuff. It's absolutely fascinating, but to say that these are just dumb stochastic parrots that can't solve riddles in mid-2026 or heading into the fall here almost is just intellectually dishonest. How can you occupy such a different universe from me? You can prove yourself wrong, British PhD. If you just went on ChatGPT or Google Gemini, or if you install one of these things locally, your whole worldview would be obliterated.